it's my great pleasure to introduce Sam Newman. 20 years ago, I was essentially a junior on Sam's team at ThoughtWorks. And back then, I remember being incredibly impressed that Sam could tell the client the absolute truth. And they still wanted him. They like you for it. That kind of continued. I remember at Euroclosure 2012, Rich Hickey was there in the audience, and we were all there very excited about Closure. Still are a little bit. We had lots of talks about the language, but I remember you kind of standing up, and you talked about Riemann or Ryman, that event kind of routing tool, and you said, you lot have to go out and build stuff. That's how this language will get traction. So again, a strong message that resonated. Sam, of course, is instrumental in things like the tech radar at ThoughtWorks, which we've kind of copied. So thank you for that. The AI radar is outside. Of course, Sam is like a famed author now for microservices and distributed computing, so a real out-there thought leader. So please put your hands together. Very excited to hear what Sam's got to say. And Sam.
Thank you, mate. But thank you, John, for that lovely introduction. I'm actually really glad I've been able to attend this time. John's asked me before, and I've always been washing my hair. And my hair's getting old, and I'm losing it. So I thought, well, I've got less hair now, so the hair washing takes a lot less time. So I want to talk to you about a bunch of ideas that have been coalescing for me. I'm going to talk a bit about uncertainty. I think as I get older, I get less certain. I don't know if that's happening to anybody else. I don't mean about my bladder control. That's not quite that old yet, but it will be coming. I'm going to be talking to you a bit about uncertainty. I'm talking to you a bit about robots, because robots are cool. And I'm also going to be talking to you about something which I think is even cooler, which is modules. Yes, that's it. I've stuck a little bit of stuff in there, but the robot stuff, I've come for the robots. And also trying to get my head around whether or not we are really getting into this new way of developing code. Is this the next step in the level of abstraction you work at, from machine code to assembly code to sort of general and system level programming languages? Isn't our AI the abstraction level for the future? And I'm really not sure. I mean, this is a talk after all about uncertainty. But what I am certain of is that we were promised jetpacks. I remember this being promised jetpacks. I also remember being promised the 10x developer, right? I'm sure many of you have purchased this book. Some of you may even have read it, right? And this is where the original myth for the 10x developer comes from. And it was rubbish back then, and it's rubbish now. But when AI came along, it wasn't just 10x. It was, no, it's going to be 50x. It's going to be 1,000x. And it turns out it's 10-something. But broadly speaking, it's about 10%, right? At the moment, at least, where we're actually looking at the uplift in general across a couple of quite large-scale studies, we're in the ballpark, industry-wide, of seeing around a 10 to 15% improvement in actual shipped code, right? Which doesn't seem great. It's not nothing. This is not nothing. I'm not sure it justifies the largest deployment of capital in human history. So, but we got numbers, graph go up and to the right. We like this, graph go up and to the right. Right, this is good. This is from GitClear. GitClear have great stats on some large-scale projects. We actually see a significant growth in terms of the net amount of code being added. So what's the issue? What's going on? I think I come back to that point that John made at the beginning, is that we are still all very much in a storm. No one knows what the hell is going on. And if someone tells you they do know what's going on, they're trying to sell you something, right? I hope I haven't offended anybody in the room. And in that, amongst that, I'm sure I'm not alone in wishing that I could just hide from the world a little bit. We're being overwhelmed by this storm, by all of these things coming in. AI was supposed to free us. Instead, we seem to have less time to think. There's also been studies, a picture of the both the DORA and the DX studies showed that amongst organizations where they're adopting AI, people are now working longer hours. Well, this isn't what we were promised. Where's our goddamn jetpack, right? So I want to try and zero in on a couple of aspects of this to try and make sense of it all. This came out with some client work I was doing, but I started looking at one specific issue. We know, for example, that we are generating more PRs, and those PRs are getting larger because AI likes generating large change sets. It's actually quite difficult to get them to generate small change sets. Now, I want to say, as an aside, I think PRs are dumb and stupid, and I've lost that argument. However, thank you, Ivan, as a fellow. I got you. But, and I actually also think if you use PRs, you're also dumb. No, I didn't say that. You can come ask me later why I think that. But I'm just trying to think through this process. So what is this causing this bottleneck? And so a conversation that's been going on quite a lot now is the concept of the human review. The human review acting as a bottleneck to our productivity. I see a few people nodding. I'm sure some of you have seen these 4 letters before. LGTM, looks good to me. This actually comes from using the Google code review system. You'd get a code review in, get a big change set, and I'd get one comment. I'd go, yeah, LGTM, you'd hit enter. And the code review system internally would take those 4 letters as an acceptance that code was good. And we know the problem. With a small change set, you're much more likely to get someone giving you real useful feedback. The larger the change set, the more likely you are for your eyes to glaze over, LGTM, and you hit enter. Some people have referred to us sort of blindly accepting the output of AI as cognitive surrender. I often feel like a bit of cognitive surrender on a Friday. But we're solving this, of course. How are we solving this? We're using AI for our code review processes now. One of my clients actually is using CodeRabbit, and they really like it, and it seems to be one of the better tools. But this then gave me pause for thought. So we've now got AI writing the code, AI is now reviewing the code, and we're using AI to change the code. Right? This is what we're doing now. So if AI is writing code for AI to then use, why are we looking at it? Because again, I come back to the whole point of this was supposed to free me up to do other things. I could be doing other things with my time, right? So let's step back a moment and think a little bit about what a code review is even for. Whether or not you do this as part of a PR process, or my preferred option would be pair programming. When we review code, there's a load of different reasons why we might want to do it. Broadly speaking, it's kind of 4 ways I think about the purpose of a code review. The first purpose is to kind of get some sense of, is the code correct? Does it look kind of right? A lot of this is about gut feel. Sometimes this can be stylistic. The process of a code review, where a human is reviewing another human's code review as well, is about shared learning. I can provide input to you, which you can take on board and learn from, and I can learn from things you did in your code. This is a touch point for us. I don't need to do this with pair programming, because that's happening in the moment, but in a code review, this is very much part of it. There's also other things like alignment to tech strategy and working practices. Are you using the coding idioms we want you to use? Are you using the libraries we expect you to be using? Or are you doing some bad things? You're sneaking functional programming into an object-oriented code base. It's like, bad developer, right? Or we've also got, and in some contexts, the fact that a code review has happened is really useful as an auditable piece of work. It's a point at which things get signed off. But if we start examining these things through the lens of AI generating code that's going to be used by AI, well, from a point of view of correctness, is the human being really going to look at a piece of code, these growing change sets, and get a sense of correctness? No, it's a really bad idea, right? Actually, that's what testing is for, right? So actually getting better at verifying, does our code work? We saw some great presentations already about this topic today, so that doesn't even stack up. In terms of shared learning, this is unidirectional, right? Primarily, this is unidirectional. We don't get to update the training of these coding models. They don't learn like neural nets. When we correct what an agent does, all we're really doing is updating some context at best case. So I don't think this shared learning thing happens either. I'm not even entirely sure the other things are standing up at this point. So I started thinking, okay, Sam, let's push the envelope a little bit. if code is being written by AI, and AI is checking it, and AI is modifying it, why don't I just say, just take the whole thing off my plate, so I don't have to deal with that anymore? And I'm putting aside the fact I still like coding, I still get that dopamine hit, but let's push it a little bit. If we really are going to be operating that new level of abstraction, let's give the code to AI wholesale. The idea being that we can reduce the load on developers and we can focus our time on what's important. This is controversial, very controversial. So let's take a look at this from different angles. Let's talk about robots. Robots are cool. They are objectively cool as far as I'm concerned. And a lot of time we think about robots, we're often thinking in the context of industrial robots. And industrial robots are typically designed for things like car manufacturing, right? This is a good example of some industrial robots. These are Amazon's Hercules robots. They're really amazing things. They're bought from a company called Kiva. This is actually how the e-commerce fulfillment works. These little robots zip around, and then they go under a shelf, and there's a screw that lifts that shelf up, and it brings that to where people are doing work. So if you've ever worked in warehouse logistics, the pick and the pack process, rather than somebody going around the warehouse picking items off the shelf comes to you. The reason the shelf comes to you is you can't go in there because you will die, right? These things will just crush you like a little bug. Industrial robots need to operate within a safety zone because they are not designed to operate in concert with human beings. Sometimes these safety zones are enforced by things like microsensors and the like, or more commonly, just a big cage. The robot is in the cage, you are not in the cage. Now we take this idea of automation through robots like this, industrial robots like this, we can take it to the logical conclusion, which are what are called dark factories. These are sometimes known as lights-off factories. If you can have a fully automated facility where there are no lights on because the lights are there for human beings. So these are being used all over the world now. I tried looking for good pictures of dark factories. They're all AI. Because why? Because the lights are off, so you can't take a real photo of it. It was quite frustrating. I did find this one. This is a really bad photo, but it's actually a real dark factory. This is actually in India. This is in Tamil Nadu. And it's really interesting, right? Because this is the only thing that's on. You can hear there's a prayer loop going, which I think was quite nice, right? That's all you've got going on, but it works. It's a dark factory. It's a completely hands-off environment. And so, could I do this? Could I create a dark factory? Could I just build the factory for my code? And fundamentally, this is what a few people are starting to talk about now with this thing called loop engineering. So I don't know if any of you want to dive a bit deeper into this. I'm not going to go into it in a lot of detail now because the topic's quite fluid. But Addy's got a really great post on this. But loop engineering is a way for you to spend loads of money on tokens rather than just a lot of money on tokens. But the idea is that you basically have agents supervising other agents, and you let this thing iterate until it gives you the right answer. It's not quite a genetic algorithm approach because, it might take all of your money out of your bank account, but there's some ideas happening. So then we could have AI create code for us in these dark factories. In the same way as we build a dark factory facility, we say, this is what I want this factory to produce. Here are the inputs, here are the outputs, go do your job. Now, of course, this idea sounds absolutely insane, doesn't it? I see Ivan is looking at me like he's already regretting ever working with me. It does seem a bit insane, doesn't it? So let's push this a little bit more. Who here has outsourced some development of a system before? Hands up, right? So you've gone to other people and said, write this code for me. Yeah. Did you check all the code they gave you back? Yes, some of you are saying yes, and you're liars, because I've worked on those projects, and I know you didn't. I know the vast majority of you who outsource software code delivery did not even go as far as to say, talk about the quality of the code in your contracts, because, again, I've been on the other side of those negotiations. How many of you have used a third-party library? Lots of you have, right? Of course you have. Those of you without your hands up, again, you're asleep. So that's fine. Did you check all the code in there? You didn't check all the code, no. You don't necessarily know how that code was written. You may not even have a handle on the software delivery processes those people were using. So we kind of already do some of this. We already have this notion of outsourcing in some way the delivery of our code to other people over which we don't have complete oversight. And arguably, some of those models are more risky than the code we write ourselves, and yet we hold our own code sometimes to higher standards than the third-party code we rely upon. But no, this idea, Sam, is too risky. We can't do it. Our code is too risky. We cannot possibly even consider these ideas. Is all code equal? Absolutely not. Right? Our code isn't like this. Our work is not producing pencils where we want each pencil to be the same as the other. This is why you do not use lines of code as a measurement of productivity. That is not our job. Code is different. It's not uniform. It varies. What we do with it changes. The importance to our system varies. The risk profile varies. And yet we seem to want to squeeze all of our code through the same process, as though it's got to be done exactly the same everywhere. But yet, again, we have exceptions for code we outsource or for our third-party libraries or the libraries of the vendors and everything else. So if our code is different, why should we treat it the same? So come back to robotics. So in robotics, I talked about industrial robots. There's another type of robot that you might encounter, and that's what's called a cobot. And cobots come in many shape and size, but these are robots which are designed to work in the same space as humans. So industrial robots are not designed to share the same workspace as humans. They don't have the ergonomics. They are often dangerous. They have sharp, pointy edges. Cobots are designed to work in concert with the human being. There is no need for a safety zone. At the most extreme end, we have examples of cobots used in surgical procedures. This example here is a cobot being used this is a simulated laparoscopy. So this is a robot designed with the ergonomics where we've got quite a risky procedure, and these two things are supporting each other, the human and the robot working together. This stands in quite stark contrast to kind of the industrial robot aesthetic. So we have situations where we've got an industrial robot sitting over there doing stuff by itself, maybe now in a dark factory, creating dark modules, maybe. And then we can have another type of working model over here where we work very closely hand in glove with the AI. I'm sure some of you have seen this kind of concept before, right? This is a Wardley map. I think it's an imperfect instrument, because all models are to an extent, and this is often used at kind of more the enterprise level. But when we start thinking about what our code does, there are parts of our code that is not as important as other parts of our system, that isn't as critical. And that, for me, then starts to say, well, if we're thinking that this might be a new brave frontier, that AI really is the next step, then where can we safely push the envelope? So what about saying, look, for the really important code, that's the stuff where it's so critical to what we do, that is a place where we need to work hand in glove with the AI, find new ways of understanding the code and appreciating the code. But for other stuff, just give it to the AI and get on with your life. The challenge is that for many of you, and many of my clients, this is what your system looks like. Blob. You don't get to make different choices in blob. It's just blob. So we need to think of our code more like this, maybe not the uniformity of this, but we need to go back to cutting-edge ideas that come to us from 1971. Parnas's work. The groundwork for modules was laid even earlier than that. We start to think about our systems as a set of modules. We can make different choices in those modules. We can make different choices in terms of how we develop those modules. Historically, we've talked about modularity in terms of concepts like information hiding, in terms of volatility, independent deployability, changing technology, and those are all useful as well. But if we want to experiment and push the envelope with different ways of working, modularity here is a really useful tool to us, allowing us to make maybe different choices about where we're going to do things. We can outsource maybe some of these modules to AI. Coming back to that concept of third-party libraries, right? We use third-party libraries, and the reason we do is because they give us something useful, right? Same reason we open source code. We outsource code because we don't have the capacity. But the reason we feel confident doing it in both cases comes down to this word: it's trust. So then for me, the equation shifts down to how do we build trust? If I'm thinking about outsourcing my code, I need to build trust in the vendor I'm working with. I'm going to have meetings. I'm going to meet the team. If I'm going to put in an open source library, I'm going to rely on maybe the group that builds it, the community around it, word of mouth. I bet a lot of you don't even check the build statuses on GitHub when you add a new library. I know I don't, right? But we do kind of have some sense of how we go about building that trust. How much do you trust your AI agent at the moment? And this is the problem, really, is whatever we're being promised, establishing a degree in trust in what our AI agent is going to do is tricky. And that's not just because the AI agents themselves sometimes will do the wrong thing. It's also because fundamentally, if you spend any time looking into what's going on, especially with OpenAI and Anthropic, do we really trust the vendors? Absolutely not. So this becomes, I think, in some ways, a potential barrier to us. But if we are going to move towards a world where we're giving more of this code to AI to build for us, if we really are going to construct dark factories, constructing dark modules, one thing is for certain, it's that testing becomes even more important. I was on a panel recently, and a younger developer said, I've just started out as a developer. I want to make sure I can find a job. What should I do? And I said, get really good at test automation. There is no world in which we need fewer people doing test automation. And it was great to see the property-based testing discussion we had earlier. But it's not just testing. Observability also becomes vital. Talking to Charity Majors, who's the founder at Honeycomb, the other day, and she said that we used to kid ourselves that our distributed systems were deterministic. They're not deterministic. They involve too many things which do not give a deterministic property overall. I once had rabbits eat my network cable, right? How do you account for that? All we're doing, though, is now increasing the amount of non-determinism into our systems. And so getting a sense of what's happening inside that becomes really, really important. A dark factory has the ability to tell you what's going on internally. So we need to have good testing, we need to have good observability, and maybe we'll get to a point where we can have these fully automated factories working away for us. Don't know if that's going to be true, though. I still deal with this uncertainty. I also really dislike this slide I've showed. It implies a linear progression. A few people here today have talked about maturity and how we improve the maturity and how teams become more mature. I hate maturity models, always have. Maturity models imply a linear progression, as though getting to the end is the right thing to do. I'm not sure that's true. I think when it comes to software delivery, the only maturity I care about is your improving ability to think critically. Critical thinking that's the maturity I care about. And at the moment, I'm worried that our use of AI might be undermining that. But coming back to the original idea, I think as we can increase our trust in the AI we are using to deliver our software, that opens up the possibility for us to reduce our human involvement. I think the challenge we've got is that a lot of our development practices are not thought through. They are a form of ceremony. We adopted the PR process not because it was a good process, right? We're using Git because Linus wanted a different version control tool to update the kernel in Linux, which bears no relation to the software delivery that any of you do. So much of what we do, our development practices, were accidental decisions made by some arbitrary person some time ago. And we're copying them without really thinking critically, what are we doing? What kind of reviews do we need? Are we more in the world of wanting to work hand in glove with our AI, in which case we may need agentic models and working relationships that are defined around that way of working. It's not necessarily going to be a one-size-fits-all. There's a big difference between a surgical cobot and a different type of cobot. Right? If we look in the world of robotics, there are different types of cobots. We can think about something like the Roomba, right? Which is a cobot. It's designed to share the same space as us, but we're not interacting. So I don't even think it's going to be as simple as we're either dark modules or not. I think we're probably looking at a progression of different ways of working. Whether or not dark factories are our future or not, I think we've got to focus on this idea of making sure that the humans have more time to do things which are human. So stepping back, if we are going to free up time, where is it vital that humans spend their time? I'm glad I wasn't the only person to mention the Peter Nauer piece. This comes from the theory of programming, which I heard about earlier. A central part of any program, the theory of it is something that could not be conceivably be expressed, but is inextricably bound to human beings. This is the program as a theory that lives in the minds of the developers. It's we who understand the system. It's a collection. The software we build is socio-technical systems. It's not just code. Code is at best an imperfect reflection of what we're trying to achieve. So with this in mind, where do we free ourselves up to think about the theory of the program? For me, it comes back to boxes and arrows. It's always boxes and arrows. Let's think about architecture. Our boxes and arrows. As a human being, where would I focus my time right now? The arrows, the connections between these things. Not rocket science, people. It's hard to change boundaries in our system. So getting this right requires careful thought. This is where we need to free ourselves up to have time to think about what those boundaries should be. The interfaces between the modules in our system, they are fundamentally user interface. LLMs are lousy at user interfaces. Do you know who's very good at understanding what makes for a good interface? Humans, because humans use human interfaces. And an API, be it in process or out of process, is fundamentally a user interface. We can start to treat the different parts of our systems in terms of inputs and outputs. If we are going to create dark factories, we can think about the things that come in and the things that we expect to go out. These become the verification points for our system. So if we start thinking about our software in a properly modular sense, this opens us up to experiment with different ways of pushing the envelope with AI. Maybe in some modules, we develop it in a more of a sequential model. You go, then the AI goes, and you go, and the AI goes. Maybe in other parts, it's the much more high touch, the highly collaborative Cobot model, like the surgical model, where we're working hand in glove. And other parts of our system, we just say, oh, it's hands off. But that's the inside the box. As the human being, we still think about the shape of the box, the interface of the box. And I think for me, this is sort of how I'm trying to deal with the uncertainty we've got coming up. If anyone tells you with certainty about what's going to happen in the world of AI in the next few years, they're either lying to you or lying to themselves. There is no more certainty than uncertainty. And for me, I keep coming back to this idea that we do not know what's coming up. So with my architect hat on, how do we hedge? How do we give ourselves the space to change direction when we need to? And it feels to me that modular architectures are still the perfect hedge against an uncertain future. But fundamentally, whatever comes up next, if AI is going to work for development long term, for software delivery long term, then it needs to free us up to be more human. We've probably got to maybe think about what that means to us. I don't know. I'm not sure. But I'm sure about this. Don't know what the future's going to look like, but if this isn't part of it, I don't think it's going to work. So, some take-homes before you all go and get a drink. If you have manual human reviews of code changes, I'm not saying stop it, but have a conversation about why you do it. What is it you're expecting to get out of that process? Be really intentional around this rather than using it as some sort of performance act. Identify boundaries in your system where you can start to vary working practices. There are so many other benefits that come from modular architectures, but this is a really good reason There's a whole other set of conversations I could have with you about the security benefits of properly modularized architectures, especially when it comes to LLMs. You're going to have to take time to build trust in AI. That means AI and your use of it. Work put into improved test automation and verification is going to be really important. And just recognize as well that our near future is likely going to be a range of working models. It is not going to be one size fits all. Do not get caught up with this idea that you're on a linear path to some level 5 capability AI model. Doesn't work. It's a box-ticking exercise. What you want to work on is your and your team's ability to think critically about what you need. I've written a bunch more stuff about this. I've got a thing up on LinkedIn, because I have to say that. But you can also, I've got linked to all this stuff in the slides. If you head over to these slides, you can find out more information about my latest book. I'm about finishing off a book on how you build resilient distributed systems, including lots of rants about AI, both good and bad in that as well. But thank you so much for your time. Do we have a question? There's a question right at the back.
I'm just curious as to why you stopped at architecture, because you were quite happy to go all the way there and then stop. But what makes you think that AI will not do that as well? It just seems to be a random place to stop because it's convenient.
Because I have no faith in the current obsession with LLMs to be able to get anything like that. I mean, we've reduced the world of AI to LLMs, right? And that is a fundamentally reductive model. And there doesn't seem to be any interest seriously in looking more beyond that, right? This whole race to the bottom, right? If we were talking about AI-based solutions that had a concept of, simple things like causality, maybe I'd have a bit more faith, but not right now. And there's enough speculative bullcrap in the world of AI without me speculating too far off in the distance. I want to do things that I could maybe do something with the next 6 to 12 months.
Like we're stopping now.
No, I don't.
Reach the end.
I don't think AI is stopping. I think there's a couple of companies that are going to be stopped by financial realities. Whether or not that becomes a fatal blow to our exploration of AI, I don't think so. Neural nets are deterministic. They train differently. They have been used before, and they are being used now. World models have been a thing for over 30 years. They're used widely in games. Those concepts will still be evolved and developed. So maybe in the future, but not the near future.
I loved that talk. That was awesome. Thank you very much. Our favorite cobots, it's the 21st century. We have printers, and printers fail all the time. They're designed to fail, almost by the economics of being able to get a replacement really quickly. And it fills some sort of economic purpose for the companies that create them, perhaps. So how can we trust that our AI providers have our best intentions at heart inherently?
Oh, I don't believe they do.
Yeah.
I mean, absolutely, I don't think they do. I think they've shown they have scant regard for society. They don't really care about the impact of society they have. They care about the dollar. Now, again, I'm optimistic in as much as if we see an Anthropic or an OpenAI crash, it will take a few companies with it. Hopefully Oracle will go as well. But those open source models are there now and are being useful. There are good companies out there running viable businesses, profitable businesses, just doing inference on open source AI models. So for me, I don't trust them. Doesn't mean we can't trust ourselves or trust other vendors that come down the pipe. I don't think we have to be so gloomy as to assume that all use of AI is inevitably going to be intuitified. But maybe I'm being too optimistic. I don't know.
One more question. Raise your hand. Anyone?
Thank you.